Software engineering is a systematic, disciplined, and measurable approach to the development, operation, and maintenance of software. Think of the difference between building a shed and constructing a skyscraper. Complex software needs blueprints, specialists, safety checks, and a plan from start to finish. Software runs our world, from banking apps to air traffic control. Software engineering reduces risk and improves quality, reliability, and maintainability. It helps teams deliver on time and within budget. It is not just about writing code, it applies engineering principles to the entire lifecycle. It guides an idea from a sketch to a robust product used by millions. It is the bedrock of the digital economy, functional, safe, secure, and dependable. Engineers plan features, design UIs and databases, write code, test, deploy, and maintain. These principles turn a hobbyist into a professional able to scale impact. A software process model is a simplified roadmap of how a team turns ideas into maintained software. It covers the journey from first concept to release and maintenance. Waterfall is linear and sequential. Each phase completes before the next, effective when requirements are stable. Incremental delivers in pieces. Each cycle does requirements, design, build, test. First login, then profile, then more features. Users see value early. Spiral is risk-driven, looping through planning, risk analysis, engineering, and evaluation. Agile prioritizes flexibility, collaboration, and customer feedback. Short sprints of 1-4 weeks with self-organizing teams working closely with customers. It adapts to change and ensures the product meets real needs. DevOps bridges development and operations with collaboration and shared responsibility. Automate building, testing, and releasing using CI/CD to ship faster and reliably. Extends Agile across the entire delivery pipeline from commit to production. The SDLC is the structured framework within which process models operate. Planning and requirement analysis define the problem and scope. Design the architecture and interfaces. Develop the software according to the spec. Test thoroughly to find and fix defects. Deploy to users, then monitor and maintain. Engineers attend stand-ups, code, review, debug, and collaborate across phases. The SDLC improves quality, predictability, and cost control. Requirements engineering defines, documents, and maintains what the software must do. Poor requirements risk building the wrong, unusable product. Two types, functional and non-functional. Functional define what the system does. Add to cart, pay by credit card. Non-functional define how it performs. Performance, security, reliability, usability. Interviews go deep with customers, users, and managers. Surveys gather breadth and quantitative insights across many users. Use cases capture user goals. Observation reveals context. Prototypes validate early. A clear, complete specification prevents costly rework. A use case diagram gives a high-level view of system functionality and who can do what. Actors can be users or external systems. Ovals are the actions. Each use case has a template: name, primary actor, goal, and main success scenario. Steps: user enters credentials, system validates, access granted to dashboard, include alternative flows and preconditions, for example, wrong password, account must exist. Use case diagrams clarify scope without drowning in detail. A sequence diagram shows how an interaction unfolds over time via messages between components. Common lifelines: UI, controller, and database. UI sends login to auth controller, controller queries database, verifies, returns success to UI. A class diagram captures classes, attributes, methods, and relationships. Student has attributes like student ID, name, date of birth, and methods like enroll course and calculate age. Association, aggregation, and composition express how classes relate and own parts. Sequence diagrams clarify behavior. Class diagrams define structure. Together they guide implementation. A state machine models how a single object changes state in response to events. Example: green, yellow, red on timer events. Subscription, trial, active, canceled or expired based on user actions and payments. A deployment diagram maps software artifacts onto hardware nodes and their connections. Nodes like web server, app server, database, artifacts like web app, services, schema, links labeled HTTP, helps plan performance, scalability, and reliability by visualizing runtime topology. State machines prevent invalid states, deployment diagrams prevent bottlenecks and guide ops.